Okay, so first, it switched over to chapter 7, but there is a ton of prerequisites for chapter 7 that are in chapter 6. So I don't think a lot of you actually realize you can do this. So if you click the little drop down button here, you'll see chapter 7 and stuff like that. If you click on chapter 6, it will show you all the chapters and topics in chapter 6 that you still need to do chapter 7. So there's probably a bunch of topics still in chapter 6 that are unlocked for you. That'll fill in chapter 6 and prepare you for chapter 7, which you need to do anyway. So I would work on those this week. That'll also help practice for your test and stuff like that. But it'll also allow you to get that little bit of practice and stuff in there to do chapter 7 starting next week.
So chapter 7 and then
so when you click on your normal home, when you go to your learn topics, it's going to come up with the chapter 7 stuff. Just click that little drop down, and then you'll see all the topics listed and everything else. If you click chapter 6, it will show you the topics in chapter 6. Notice some of them are locked, but because it's not available, if you go to filters, you can click just unlocked, and it'll show you just the topics that you need to do the next episode.
To go in there to work on chapter 6.
Yeah. So you just go over to filters and click unlocked. It'll only show you the topics that are unlocked. Okay.
When's it all going to unlock?
Right after Thanksgiving. So at least that's the hope, because they changed something on their end. So I used to be able to set it that it'll automatically unlock, and I don't have that option anymore. So I'm hoping it all unlocks at that point. If not, I just change all the end dates and it'll all be unlocked. So either way, after the Sunday after Thanksgiving, everything will unlock. So you'll have that time afterwards to finish filling in holes and stuff. So it will be that way no matter what, even if I have to screw around some other stuff. All right, let's look at the chapter 6 task review. Let's do this. All right, so there's 10 questions on the test. Let's go through and do some of them. So the first question is talking about area of a sector. So it wants to find the area of the clean region of the windshield. So what was the formula for area of a sector? Okay. I know. I was letting people finish writing the problem now. All right, so we've got our formula. So this one wants to know this shaded region in here, or this region right in here. So it gave us two pieces of information. It gave us the radius of the full section and the radius of the piece that doesn't actually get cleaned. So to find the area of the shaded part, I have to find the area of both of them and subtract them. So we have the larger area. So 1/2 my radius is 81 squared. And my theta is 130 degrees, but I need that in what? I need it in radians. So remember, it's 130 degrees times the pi over 180. We'll change it into radians. So if you want, you can just do 130 pi over 180. Just leave it literally like that, because you're going to type it all in the calculator anyway. So if you type that into a calculator, you're going to get So now we got to find that that little section, right? So we're going to do the exact same thing. We just do 32. And it's still going to be 130 pi over 180. So 1161.7. Huh? Yep. And we're going to subtract those two numbers.
The way Alex had you doing it, the way it showed it, if you put both of the numbers in the same exact time.
You could, but I think it's easier to just do them separately. So we got, when you subtract them, you should get 6281.5. So yeah. So yeah, when you're looking at them, honestly, you could have put the two equations together and subtracted the radiuses and done it that way. But whenever you're looking for pieces like this, a lot of times it's just easier to do the parts and do the subtraction stuff afterwards. Less little things to make mistakes, also less little things you have to remember to do. So all right. Any questions on finding area of sectors? Big pieces is remember the formula and remember to change your radius. Your if it's in degrees, you have to change it to radians. Okay, so remember that piece there. And since you're using Desmos or a calculator to do it anyway, you don't necessarily need to simplify the fraction down before you put it in. So just leave it as like I did the 130 pi over 180. So don't worry about simplifying, even though that one's simple to do. Some of them are not as simple to do. All right, next question. So this one, it's giving you theta is 135, and it wants you to find the exact value of each of the ones below. It wants exact values. That matters. So we can't just put this into Desmos and get the answer because it's going to give it to you as a decimal, not an exact value. So it's cosine squared theta and cosine 2 at theta. Unit circle comes into play. Yes, you definitely need to look at the unit circle for this one. So if you remember, we're basically always go back to the first quadrant. So theta of 135 is its reference angle is 45 degrees. Okay, it's just the 45 degree that's in the second quadrant. So all these are looking at cosine. So what is cosine of 45 degrees? Square root of 2 over 2. Okay, so that's in the first quadrant. The A is looking at cosine of negative 135. Which quadrant is that in? So if you look at your quadrants, if we're going back, it's going to be somewhere over here. So it's going to be in the third quadrant. So cosine in the third quadrant is what? Positive or negative? It is negative. So that is going to be negative square root of 2 over 2. Okay. I'm going to skip B for 1 second. We're going to do C first. So this one's looking for 2 times that, so it's looking for cosine of 270 degrees. So 270 degrees, its reference angle is going to be, actually 270 degrees is straight down, right? So what's cosine at 270 degrees? It goes from 1 to 0 to -1 to 0 back to 1. So this is 0.
So it's always the X value.
For cosine, yeah. Cosine's X, sine is Y. If you remember tangent is sine over cosine, right?
Yeah.
So its tangent goes right along with slope. Slope is rise over run, y over x. So you can make those connections back to it. All right, so now let's look at cosine of squared theta. So now the cosine, when it has the squared there, it is the same thing as saying cosine theta squared. Those mean the exact same thing. You're not squaring the angle, you're squaring the answer. So cosine of 135 is in the second quadrant. Cosine is positive or negative in the second quadrant. It's negative, it's the x value. So it's negative square root of 2 over 2. So we're going to take that answer and square it. So we get 2 over 4, which is 1/2. Now this one, the angle is going to constantly change, and the it'll be a cosine or sine for these. The negative theta, the squared, and the two might change, but the negative, I know the negative theta and the squared is always going to be in this topic. Yes, I will give you the unit circle, and on the back of the unit circle will be the parent functions, parent function tables. Huh? Yeah, you still have your note card. The reason I'm giving you the unit circle and the parent functions is because everybody's going to want those, and I don't want you to actually use those and have all writing all over it beforehand, which is exactly what happened the last one of the time I did it. So I'm like, I just give you those, and you get your note card to write your stuff on it. And honestly, the note card's not enough room to put all that stuff on it, so that's why. All right, next. Oh. Let me put my answers in. Oh, that was negative, wasn't it? Okay. All right. Next one. Same basic concept, except these are going to be, these can include the tangents and the reciprocal functions. So we've got 960 degrees. The first thing I've got to do to that is I've got to get it between 0 and 360. If I subtract 360, I get 600 minus 360 again. I get 240. All right, so I'm looking for the tangent of 240. So if I look at my, that's going to be down here somewhere. And if I look at that, my reference angle is 60 degrees. So what is sine of 60 over cosine of 60? Just tangent sine over cosine. So it's sine of 60. Yeah. So I've got root 3 over 2. And cosine of 60 is 1/2. So that ends up giving me the square root of 3.
You do that straight up in the calculator.
It'll give it to you as a decimal. So yes, you could, but it's going to give you the decimal answer of square root of 30 or the root 3. So, all right. So we've got root 3 tangent in the third quadrant is going to be positive. Because remember, it's sine is going to be negative and cosine is going to be negative in the third quadrant. So that's going to be a positive square root of 3. All right, so now we're looking at cosecant of negative 5 pi over 4. So if I do negative 5 pi over 4 plus 2 pi to get it within the unit circle, it gives me 3 pi over 4. And cosecant is which function? Is sine. So it's 1 over sine of 3 pi over 4. So its reference angle is pi over 4. So what's sine of pi over 4? Square root of 2 over 2. Second quadrant for sine is going to be positive because it's the y value. So this ends up giving me 2 over the square root of 2. And I believe Alex wants you to rationalize it. So the answer is the square root of 2.
Would you accept 2 over the square root of 2?
I like my things rationalized. I'd probably take off a point for it. I would mark it wrong, but I'd probably take off a point for it. What was the first one? Square root of 3.
So wait, so why does that become?
So whenever you're rationalizing, you multiply the top and the bottom by the square root. So that's where the 2 square root of 2 comes from. The bottom just it's 2 because that's the square root of 4, which is 2. And then the 2 2's cancel out. Yeah.
Isn't negative 5 pi over 4 another quadrant?
No, because
Oh, it's 5.
yeah, because you're going so negative would be 4 pi over 4 is back to there, and then you still go up 1 1. So that's why a lot of times that's why I say like this one technically you didn't have to do the conversion because it's still technically within one rotation of it makes it simple, but it's always easier to look at the unit circle in positive values. So that's why I added how to get the 3 pi over 4. So you don't make that little mistake in which quadrant it's going to be in. All right. Next one. We're looking at period amplitude and phase shift. All right, so the simplest one out of the whole group is amplitude. Amplitude is always going to be whatever number is in front of the thing. So my amplitude in this case is 4. Period and phase shift are both dealing with what's inside the trig function. So we're going to take this and I'm going to make one change to it first. So we're going to actually, you factor out whatever's in front of the pi, whatever's in front of the x. So we have pi over x, or pi x plus pi over 4. So you're going to take that out. So I have the pi, and then I have x. Pi over 4 divided by pi is just 1/4. Then that is your period. And that is your phase shift. So pi and 1/4. Hmm? Oh, shoot. What did I do wrong? No, the 1 actually wasn't the problem. My period's wrong. Right. I forgot the 2 pi divided by b. I forgot. That's b. So period is 2 pi divided by b. So in this case, my period is 2 pi divided by pi. So my period is 2. I did forget that. My period is 2. And one little thing. Inside here is always going to be a negative typically. So it's the reverse of that. So it's negative 1/4. I did miss the sign.
Why is it negative?
Because the actual the general format, remember it's always opposite of what's inside when you're doing it. So it would end up being bx minus c. So since it's a plus, it has to be a minus.
So if it's a minus, it has to be plus.
Yeah. Let's do another one of those. All right, amplitude's easy. -2. Yeah, this right here, that's by vertical shift. So if it's asking for vertical shift, that would be there, but this topic should just ask you for amplitude, phase shift, and period. So I've got the 3x plus pi over 2. I'm going to pull out the 3. So x plus pi over 6. I haven't changed that part yet. Yes. Yeah. Actually, hold on. I'm going to actually put it in. You can, it can be either, but I'm going to actually put in the -2. I'm going to see if it actually gives me right. Because technically you can do either way, because it's just a matter of direction. Let me see what it actually comes up with. I wouldn't care if you put -2. Let's put it that way. Phase shift is, I just want to get the other two pieces right. Yeah, it does want the positive in there.
So one fault.
No, it just wants the positive value for the amplitude.
So for the test, you don't care.
No, because technically amplitude it's the direction. So by having that piece there would be fine.
I hit 2 anything.
Yeah. And actually understanding the direction it goes is actually just as important. So knowing that it's going down to -2 first would actually be important. So that's fine. That I'm not worried about. Alex does though. But it doesn't mark it wrong. It tells you it's partially correct, so you can fix it, which is nice. All right. So now let's look over here. Phase shift is the opposite of that. So it's going to be -pi/6. And then my period is 2 pi/3. So 2/3 pi.
Does it matter if it's
Nope, doesn't matter either way. Because if you multiply, it's always going to go up on the top anyway. So if you put it up top or put it next to it, it's the same thing. Just don't put it in the bottom. That would be wrong. 2 pi/b. Yeah. All right. On the test, these will actually all be listed out, and you're just going to pick which one you want. So cosine. Domain is what? Is all real numbers. You can plug any number you want for it. So it's all real numbers. The range, cosine goes from what to what? -1 to 1. If that was sine, would they have been different? No, sine and cosine are exactly the same for domain and range. Okay. All real numbers go into it, and it's only between -1 and 1. Tangent, your domain. So we have values that don't work, right? Remember when you're graphing tangent, you have the vertical asymptotes? Those vertical asymptotes appear at what?
2.
Pi/2 is the first one. What's the second one? Which would be what? 3 pi/2. Okay, so yes, if it would be undefined, that's why. But they're looking for the actual value. So pi/2, 3 pi/2. What do you think would be the next one? 5 pi/2. And then 7 pi/2. 9 pi/2. So they are all what? Odd. Except for the odd integer multiples. And then the range of tangent, all real numbers, goes from top to bottom. What about cotangent? So cotangent is the range is still the same, all real numbers.
I thought it was the CSC.
I know I'm doing.
Oh.
I did sine and cosine for the first one to make sure you understood those, because it might not be those three that you see on the test. Yeah, because there's only 6 trig functions. So cotangent is cosine over sine, right? So we're looking at where sine doesn't exist. Where's sine 0? Where is sine 0? At 0, right?
Oh, wait.
And at pi, correct? So cotangent will not work at 0, at pi, 2 pi, at 3 pi. So integer multiples of pi. See right here, instead of all real numbers except integer multiples of pi, because they don't exist at 0, pi, 2 pi, 3 pi, and so on. All right, next one. Cosecant. Cosecant is the inverse of what? Sine. So again, it can't exist where sine is 0 because that's in the denominator, correct? So where is sine 0? We just did that one. 0 pi. So it's all the multiples of pi. What about its range? Yeah. So what you can do for this, if you can't remember this, just throw it in Desmos. Look what happens to cosecant. There's nothing between -1 and 1. So it's all the values outside of those. So there's no way to get a decimal answer, basically, or a fractional answer between -1 and 1. No, there is a range. It's all numbers less than or equal to -1 and greater than or equal to 1. It's the opposite extremes. What would be the difference if this was secant? Yeah, the range would still stay the same. The domain would be the same, would be where cosine doesn't equal 0, which is pi over 2, 3 pi over 2, 5 pi over 2, 6, 7 pi over 2, the odd integer multiples of pi over 2. Because it's 1 over cosine in that situation. So you'll have basically for your domain and range all the options, and you're just going to pick which one's correct for each one of those. Actually, I take that back because honestly, that just makes me put this massive table on things. I'm just going to ask you for the domain and range of 3 functions. So it's just going to say, give me the domain and range of these 3 functions on the test.
But we're gonna have to actually.
You'll have to write it down. I might. I don't know. I'll decide.
Do we have to do it like proper form?
No. If you write it and what you write is correct, it's fine.
Still use the Desmos.
Yeah, you can still use Desmos. Definitely use Desmos. Desmos is nice. Desmos helps. All right. We're writing an equation with this with sine or cosine. So sine and cosine are basically the exact same. They're just shifted, correct? Okay. So in a situation like this problem, you could choose either one of them and be correct. It just depends on how you tell me it's shifted. All right. If there's 2 things where that wouldn't be true. If that point right there was exactly here, use cosine. You could use sine, but there's no point. Okay, so if the minimum point or the maximum point is on the y-axis, use cosine. If it goes right through, like if the center piece goes right through the origin, use sine. There's, again, no point using cosine because you're going to have to do more work. All right. In this situation, neither of those is true. So you could technically use either one depending on which one you wanted to go with. I'm going to use cosine because shifting this little piece here is going to be easier than shifting that part over there. So it's a little bit easier to use cosine in this situation than sine. But it doesn't make a difference to me whichever one you use as long as it comes out to be the correct answer. Okay. So remember the general format is a cosine. And then it was bx plus or minus c. plus D. All right, so step one, let's figure out, we look at the min and the max. In this case, my min's at -3 and my max is at 3. Okay, so that means my amplitude is 3. Question is it +3 or -3? Why? Right, because cosine typically starts positive. This one's starting negative. So I'm going to use -3 for that. Since the min and max are exactly the same value, my D is 0. It is not shifted up or down. Okay? If my min and max were different, that would mean it's been shifted. All right? So say my min was at -2 and my max was at 4. It was shifted up 1. So my D would have changed in that situation. So, but if your min and max are exactly the same, it's not shifted up or down anything. So my D is 0 in this situation. So I don't have to worry about D in that problem. B is looking at your period. So we're looking at, in this case, since I'm using cosine, I'm looking for the minimum to the minimum again. So I'm going from, this looks like these are split in half. So this is pi/6 to 9 pi/6. So 1 period is 8 pi/6. That's my period. Huh? Yeah. So I'm going from 9 pi/6 minus the pi/6. And my period is 2 pi over b, right? Correct? Yeah. So in this case, my b is going to be, hold on.
You can do that for that.
I need to find b to put into my equation, yeah. So b is 3 pi/2. So 3/2, actually. I knew I forgot to put extra set of parentheses there.
So the period is the 8 pi/6. And the period is the
Yeah. Because you're not going to get your b from the equation, you're going to get your period. And then you have to then find the b to put in the equation. All right, and now I'm shifting over pi/6, correct? I'm shifting to the positive side, right? So it's going to be minus pi/6. So 3/2 x minus pi/6 plus 0. No, it's the opposite of it. It's always the opposite. So I'm going to the right. No, sorry. Yes, I'm going to the right, which is positive, which makes it negative. Because it'd be positive pi/6, so you put it in as a negative. Always do the opposite. It is literally the hardest part to remember. I'm not going to, it's literally the hardest part to remember is which direction you're going. I've got -3 cosine 3/2 x minus. Yeah. Oh.
Does that ever go away?
What, transformations?
Yeah.
No. No. Because, so where you end up going with a lot of this stuff, like where you're going to use, where you'd end up using any of this stuff is modeling. So you'd have a bunch of data, you'd have your information, and you'd have to come up with an equation or something to model what you have there so you can predict something that's going to happen in the future. Okay, so that's typically where this stuff comes into play. So in essence, it ends up being a lot of transformations because you plot your data. It's like, okay, I want my equation to look like this. What do I need now to do the transformations from what that equation should look like? So, and there ends up being a lot of transformations down the road when you do it, where you would actually use this stuff.
Want us to leave it like this, or would you want us to,
I'll take either direction. If you want to distribute that through, you can, or you can leave it like that. Either way is right. So, and Alex will take it either way because I just put it in that way. So, and I'm not overly worried about the y equals. Alex is. So make sure to put the y equals there for Alex. But yeah, it'll take it either way. Again, I'm more concerned with, like, if for some reason you sat there, you did all this work out, and you screwed up the pi over 6 and put the plus, I'm not marking the whole thing wrong. It's like, I'm looking for understanding. It's like, okay, you got the shift, you forgot that you had to switch the sign and take off a point for that. Like, little things like that. I'm not. Like, if you had put the 8 pi over 6 in there instead of the 3 pi over 2, the 3 over 2, that's a little bit bigger of a mistake than missing the thing because you forgot to shift it over to the b. But you got your period correct, which is important, so you'll get points for that. So,
That would be 7 out of 10 points.
so okay. All right, next one. All right, so population sample, suppose this models the population. So here's my population. It's the total population size, and T is in years. Find the following information rounded to the nearest hundredth if needed. So what is the first one is the minimum population size. So remember, cosine is one of these numbers, right? It goes down then back up, correct? So my amplitude is 1250. That's my amplitude. And that was my shift. So that's the D. So it's been shifted up 3050, correct? So that's the start. And its amplitude is 1250. So 1250 would be on top of that, would be my peak, correct? So my max would be 3050 plus the 1250. And my min would be 3050 minus the 1250. Because the 3050 is the middle of my function. That's what that vertical shift does. So in this case, my max is 4275 and my min is 1850. That's not, that's, hold on. That's 4300. And that's 1800. Yeah, 1800. So in this case, my minimum population size is 1800. All right. Questions with that part? Okay. So it wants the time for one full cycle. So what's it asking for here? It's asking for my period. So remember, period is 2 pi over b. In this case, b is 1.5. So it's 2 pi over 1.5. Yeah, and it says nearest hundredth, so this one is 4.20. It's in radians. Unless they have the little degree symbol, assume it's in radians. So 99% of the time when you're looking at a model of an equation like this, it's going to be in radians. Okay, so my time for one full cycle is 4.20 years. You end up getting 4.1887. So the actually 4.19. I screwed that one up. I screwed up my rounding. 19. So how many cycles are there per year? Huh? No, one cycle takes 4.919 years. So how many cycles would there be in 1 year? Right, it's 1 divided by the 4.19. Which comes out to be 0.24. So it's 0.24 years. Okay. So again, it's really no different than what you're doing with this problem. It's just doing it as more of a word problem than just a simple equation. Like I said, this is typically where you're going to see this stuff used. You have this, and now you have to figure out what's going to happen over time. So, like, the minimum population size is 1,800. When would the next minimum population, if the minimum population happened today, when would the next minimum population happen again? $4.19 years, because that's the period. Okay. And that would be the next time the minimum value would occur. So I wrote a problem this weekend for my other thing. It was looking at rabbit populations and fox populations. And rabbit populations go up as fox populations go down because there's less predators. When the fox population's at the max, the rabbit population's at its minimum. And when the food starts running out, foxes will die off. So it's like they were looking at the two models and they had to figure out where the difference was at a specific year. So yeah, same concept. So, but populations typically are cyclical, and they model themselves very well with trig functions. Most natural phenomena model themselves very well around sine and cosine. All right, next one. I'm going to graph this function. So remember, we're using parent functions. So for cosine, 0, pi over 2, pi 3 pi over 2, 2 pi. 1, 0, negative 1, 0, 1. So this one, I'll have the graph there. The graph is a sketch. It's not, I'm obviously not going to be expecting it to be perfect when you're graphing your points. The points are more of what I'm going to look at for that. So I want to see the sketch. The sketch should look pretty accurate. But I'm going to go back to your points to make sure those are correct. So if your points are wrong, the sketch doesn't really matter much. So. All right, so remember, anything on the outside, we're doing to the y values. And we do exactly what it says. So that's 2y. So 2, 0, negative 2, 0, and 2. Inside, we do the opposite of what it says. So we're doing x plus 2 pi over 3. So 2 pi over 3. Half, so I got to do 6. So 3, 4, 7 pi over 3. Oh no, 7 pi over 6. Five pi over 3. It's going up by 6. So 13 pi over 6. 16 pi over 6 is 9 pi over 3. No, that's not right. 8 pi over 3. That's better. So in essence, I would be looking for that's what I really want to see. So somewhere on your paper, I don't care how you do your calculations, everything else, make sure those two columns are written as a pattern. So this way I can see what your points are that you're going to be graphing. Parent functions? Yes. Yeah. So I'll give on one side is going to be the unit circle, the back side will be the parent functions. I literally get to create that next period or right after this class and send it off to the copy center to make them for me. All right.
That for 2 cosine x minus 3 over 2, whatever, that's plus some 5 or something.
I won't have one where there'll be something in front of the x. There might be something at the end with the y. No, you just do it. You just would add 3 to that or whatever else it would have been to be.
Oh, so it would either be 2 would be from the cosine or minus the cosine?
Yeah. Yeah.
If you were to have,
Or I could have both. So like I could have this as plus 3, and then I would just add 3 to the y's. I won't have you do 2 things to the x. You could have to do 2 things to the y.
so if at that point you just take the
No, so I would do 2y plus 3. So my points would be 5, 3, 1, 3, 5.
so you just add.
I would add 3 to it, yeah. So I won't have anything added in with 2 things to the x because that makes it a lot more complicated because you have to split it out first. The y is not. So I could add something there. All right. The last 2 problems are right triangle stuff. No, there's 10 questions. I did I split them up. There was multiple pieces for a couple of the parts. So that's why the slides say 11. There's only 10 questions. So see, 10. There's multiple parts to some of them. Oh, actually, there's one unit. The last one's actually a harmonic. All right, so we want to look for, in this case, the x. What is the 175? That's opposite, and the 915 is Jason. So I have, which function am I going to use? Tangent. So I have tangent of x equals the 175 over 915. So in this case, I'm going to use the arctan of 175 over 915. Since this is a realistic style problem, it's in degrees.
You use the
Because I'm looking for, I need to get rid of tangent. So arctan gets rid of the tangent.
you wouldn't do it by number two.
No, because it's not going to help you in this situation. My goal is to get the x. So I need to. I closed it. That's not what I wanted to do. Hold on. No. It just I hit the when I touched I must have touched closer to the x than the. So in essence, what I'm doing, I'm gonna actually move this a little bit over. So I have to do the tangent -1 of that side and the tangent -1 of that side. Those then cancel out. I'm left with just the x.
Oh,
That's why.
that makes sense.
Okay. So do that in Desmos. When you type it in your calculator, make sure your calculator is in degrees. So we get 10.8 degrees.
Is there another way to do that without writing the tangent? Like,
No. There is not. Yes. No, this one will be in degrees. So yeah, when you're looking at your right angle or your right triangle stuff, typically that stuff's in degrees. When you're looking at your periodic stuff, that's typically in radians. So this is a right triangle, so it's in degrees. So x equals 10.8 degrees. All right. Last problem. So this one's got two parts to it. And I lied, it's a periodic one. There's only one right triangle thing on there. So first step, it wants you to graph it. And then the next step, it wants you to find some information about it. So first step, we're going to graph. So same thing, come up with my parent functions. 0 pi over 2 pi 3 pi over 2. Since this is sine, it's 0, 1, 0, -1, 0. The one on the outside I multiply, 35y. And now this one is to the x values, and I'm multiplying it. So what do I have to do? I multiply it by its reciprocal, so it's 6 over 5 pi x. So 0. So 3/5. 6/5. 9/5. And 12/5. Huh?
No, I'll
You got
stop
that?
myself.
Okay. All right. Everybody got those down? I'll plot these while you're finishing that part. All right. So we've got our graph here. It says it wants to know, find all times between 2 and 4 seconds where the weight is 30 degrees centimeters to the right. So that would be positive side. So now you're not obviously going to have this graph here. So what are you going to use?
Draw.
You can draw it, but is your drawing going to be perfect?
Oh, then
You can use Desmos. So you're going to graph it on Desmos, and you're going to find the values between 2 and 4 seconds where it's between 30 degrees. So there's 2 points in it. So we're just going to put this into Desmos so I can show you the Desmos. So that will show you exactly how to find this in Desmos. 35 sine.
you can plug that. That's going to
No. So here's what we're saying. So we're going to put it in Desmos. First thing, it looks really messy. What do I care about? I really only care about between 2 and 4, right? So let's just do 1 to 5. And I know my thing goes from goes from 35 to 35. So clean up your x-axis so you can see what's going on. And then I'm looking for 30, right? So just set an equation to y equals 30. And it gives you your values. You can also, if you want, just do this and go, okay, and find about 30 at each one. You can do that way too, but setting an equation to find it will give you the exact values. So we have 2.8 and 3.2 seconds. If it's at 30 degrees to the left, or 30 centimeters to the left, it would have been the negative version of 30. And we would have had 2 approximately and approximately 4. So 2 and 4 would have been where it's exactly 30 seconds to the left, because the left, right was positive, left would be negative. Okay. And this works for any value. So if it said 20, you just change it to 20 and get the answer there too. So,
We're plugging this into Alex. We can also use Desmos.
yeah, absolutely. Yeah. So, because like it will give you kind of close on if you're looking at the graph, but yeah, you're going to have to use Desmos to get the exact answer. I want to see something. I want to see how it actually Because there's no way you're getting the exact answer by looking at the graph. Oh, see, actually, oh, no, sorry, that's 30. They pick numbers. So here, I'll show you what they did. They pick a value that's going to be easy to look at the lines in it. So, but Desmos will give you the same answer. So it was 4, so that's 2.8 and 3.2. So they made it so that the lines actually line up to about where they are. So.
And I'm gonna do the test.
No. So you can use Desmos, which is what I told you. So. Okay. All right. That's your test. So again, it's still there. The review test is still on Alex. So my suggestion to you, as was before, go through and do it and write the stuff that you need down on your index card, knowing that I'm going to give you the unit circle and the parent function, so you do not need to have those on your index card. Okay? Yes. Yes, it'll show you the whole circle. Okay? So here, I can actually show you the unit circle I'm going to give you.
We actually graphing it or
No, you'd have to graph it, yeah. So the unit circle I'm going to give you is unit circle, not images. I want not images. Is basically this one. That's the unit circle I'm going to give you. So it'll have all that there.
I was hoping it was gonna be a good one.
Yeah. So that'll be on one side, and the parent functions will be on the back. All right. If you have no questions, you're free to go. If you have questions, even on Alex and different topics, stick around and I can go through those.
So now at
You're
Alex, we're
welcome.
working on chapter 7.